Hey, today's video is how do we apply the properties of logs. So let's jump right into it. The very first property is the product property, product multiplication, right? Well, the product property states that if we have log base b of m times n, you can break this up into an addition of log base b of m plus log base b of n. Okay, this expands out into this. Let's try that. Alright, so here we're going to try and condense log of 2 plus log of x. These each have a base of 10 because they're common logs. And because they're being added, I can represent this as the log of 2 times x. Now, if you're trying to make sense of all this, think about exponent properties, right? Whenever you have like x to the 4th times x cubed, right? These things are being multiplied, but what do you do to their exponents? You add them, right? Logs and exponents have a lot in common. See here, these are being multiplied, so we add the log of each. So what do you think is going to happen with division? All right, the next property is the quotient property, and it just shows that if you have a log with some division, you can break this down or expand it into a subtraction. Anything in a denominator will be subtracted. Okay, and you're just taking the log of each thing. So let's try that. In the last example we condensed. This time we're going to go the other way and expand this out as far as it can go. We have log base 2 of 4x over y. Well, first let's break down the numerator. That'd be log base 2 of 4, and since it's being multiplied by x, we're going to say plus log base 2 of x. And then since the y is in the denominator, we will subtract log base 2 of y. Alright, the next property that we're going to look at is the power property. And it states that whenever you are raising whatever you're taking the log of to a power, that power will actually multiply the log. Right, and thinking back to exponent properties, whenever you had power to a power, it ended up, you would multiply those numbers. Well, here we have some multiplication happening. Alright, here we're going to do two examples. Let's do a condense and an expand. Here, if I'm going to condense these, the very first thing I want to do is move these numbers out in front. These become the exponents. So we have the natural log of x squared plus the natural log of y cubed. And because they're added, I can write this as a single logarithm, x squared y cubed. Over on the other side with the expand, I know whatever is in a denominator will be subtracted. So I'm going to do the log base 3 of x cubed minus the log base 3 of y squared. And then let's just move their exponents in front. 3 log base 3 of x minus 2 log base 3 of y. Alright, so these examples are for you to try. I want you to try and expand this log and condense this log. Alright, pause the video and then come back in a second. Okay, for the first example, you should have the log of 3 plus the log of y, since they're both being multiplied. Now, these are being multiplied, but they're both in the denominator, so they'll both be subtracted. The 5 became the front of this minus 5 log x minus log z. Now in the second problem, we didn't have any variables. So we had here, this is all log base 2, right? And up in the numerator, we had 2 times 3 cubed all over 9. Well, 3 cubed is 27. 2 times that, that'd be log base 2 of 54 over 9, and that's just log base 2 of 6. Which leads us to our next question. 2 to what power is 6? Well, we don't know that, right? How could we figure this out? Well, that's the next part of the video. We can use change of base. With change of base, it lets logs with bases other than 10 or e, it gives them the ability to be written in terms of common or natural logs, which are base, 10 and e. Here's the formal definition. Log base c of a can be rewritten as the log. Now we're going to form a new base b of a all over log of, with the same base of c. So by this definition, this is always true. Like, as long as we assign them the same base, we can rewrite them like this. So why not make this base 10 or e, right? Then we can evaluate these things with the calculator. So basically, by definition, this is the same thing as me just saying the log of a over the log of c. Or this is also equal to the natural log of a over the natural log of c. All of these things are equal to each other. So let's try to evaluate something. For this part, you will need a calculator. All right, so log base 2 of 8. We know that this is 3. But just to see that the formula works, let's try it. Let's do, this would be the log of the big number 8 over the log of the base 2. Now, what base have I given both of these? Base 10, so they're the same. If you type this into the calculator, you'll see that this is equal to 3. You could also type in the natural log of 8 over the natural log of 2. It doesn't matter which one you use. Okay, but over here, we don't know 5 to what power is 8. We know it's not the second power because 5 squared is 25, but it must be a little bit more than 1 since 5 to the first is 5. So let's evaluate it. I'm going to use natural logs this time. So the natural log of 8 divided by the natural log of 5. I've given them the base e, right? So now I go to my calculator, I type this in, and I find that this is equal to 1.292, a little bit bigger than 1, just as we guessed. All right, and those are the properties of logs.